All right, as of 12/31/2013, the insurance company has a known obligation to pay $1 million on 12/31/2017 to fund this liability. The company immediately purchases 4-year, 5% annual coupon bonds totaling $822,703 at par value. The company anticipates reinvestment rates to remain constant at 5% through 12/31/2017. Maturity value of the bond equals the par value. Consider two reinvestment interest rate movement scenarios effective 1/1/2014. Scenario A has interest rate drops by 0.5%. Scenario B has interest rates increased by 0.5%. So which of the following best describes the insurance company's profit or loss as of 12/31/2017 after the liability is paid? Okay, so I just made time 0 correspond to 2013 and time 4 correspond to 2017. It makes it a lot easier to work with. Okay, so just so you know, that's how I set up my timeline. Okay, and what is each coupon payment? So that's going to equal FR. Okay, and the face value is 822,703, and the coupon rate is 5% at first before we do the reinvestment. So we do that, and we should get 41135.15. Therefore, all of these payments are that amount, 41135.15, 41135.15. Okay. Then we also have the redemption value, so 822,703. Okay, great. So, and then we have the obligation to pay of $1 million here. Okay. All right, so we have two reinvestment case scenarios. Let's break it down. Under case 1, we're going to have to accumulate. So either way, we're going to have to accumulate all of these this time over here. Okay. We're just working with different interest rates. Under scenario 1, I equals 0.5% less than 5%, so 0.045, right? Okay. So I'm going to accumulate, let's deal with the 41 first. So 41135, right? That's what this is right here. Plus 41135. And I got to accumulate that by the 1.045 because I have a 4.5% interest rate, ... And I know that I have 4 terms, okay? We don't have that many, so we can just calculate it on the calculator. But so we're going to factor out the two first terms, 41135.15. So 1 plus 1.045, ... And so now we're going to use this. The sum of a geometric sequence is the first term, so it's going to be 1 minus first omitted term, 1.045 to the 4th power, 1 minus common ratio, so 1 minus 1.045. And don't forget that this is still here, okay? So it's going to be times 41135.15. Okay? So that's directly a calculator problem, right? We just want to now calculate. So this is going to be how much we get under the scenario A, okay? It's about keeping track of stuff now. So scenario A, okay? Now, you should just realize that we're still going to have to accumulate the coupon payments but at a different interest rate. So scenario B, if you think about it, it's just going to be the same thing. So we have our 41135.15. Just use a little bit of logic. We're obviously going to have, it's going to be similar to the formula we have before, but now it's going to be 1 minus 1.055 because the interest rate is 5.5%, right? So you save yourself some time, or use a little shortcut here. Okay, so we get that. Let's calculate that on the calculator now. So this one right here and this one right here. And then we want to see what's the difference from that and $1 million. So the first one, if you do the math right, you should get, this one should be 998,687. And this one should be 1,001,322. Okay, so just looking at this one alone, we can see that if we subtract a million from it because this is our obligation to pay, right? So we know that the only choice that's even matches that is this one. Okay, so it has to be choice D, and you could check for A as well. If we do a million minus this, we'll be right around 1310 as well. Okay, so a little bit confusing wording, I think, but if you just break it down, it should make sense. Okay, we just use first principles here.